Hi everyone, welcome to the IoT Hero Show, my weekly showcase of thought leadership in the Internet of Things. My name is Tom Raftery, I'm the Global IoT Evangelist for SAP, and now, on with the show. Hi everyone, welcome to the IoT Hero Show. We are here at SAP's Sapphire Now conference, and with me I have Arnulf. Arnulf, would you like to introduce yourself?
Well, I'm managing director of Fedem Technology, which was acquired by SAP a year ago around these days.
Okay, and what is Fedem Technology? What does it do?
Fedem Technology is a technology company focusing on physics, developing software to model the behavior of things under the governance of physical law.
Okay, and why would that be important?
Well, if you have we have just heard about the Internet of Things, then you need a thing, of course, accessible to the Internet. We need to have understand the behavior of the thing in order to be able to develop more and more rich applications on top of it.
Okay. We had a big announcement here at Sapphire during the keynote about your digital twin technology. Can you tell us a little bit about that?
The presentation was about, it showed a wind turbine under influence of wind loads and the resolution of stresses. We saw the stress heat map on the structure. It was about a model of the wind turbine, and it was about a simulation that was run real time based on few sensor inputs from the north of Norway, from an actual wind turbine standing there now, processed in the cloud, and through the simulation, which is actually a structural analysis in real time, we can be able to analyze forces and moments or stresses and strains in the material.
Okay, and so this is important for our customers because
if something happens, then we will be able to detect if there is an anomalous situation. We have to recognize that the basics, Leonardo da Vinci, he was the inventor of modern science in the sense that observation was his method. He observed through his sensors, the eyes. So he looked for relationships in the human body or in the nature. And from there we have developed, in essence, when we have a sensor, we're observing nature. So what we're doing is we're observing not only in the physical sensors, but also with the virtual sensors. We use a virtual model to observe the relationships of nature. And this is of course important because if the behavior then becomes anomalous, for instance, you have a breach in the structural integrity, it will be detectable in some sense because the structure doesn't behave logically according to the laws of physics. Or if, for instance, fatigue is about how many stress cycles a particular component can be exposed to. For instance, the bolt here, and that means that if we can count the stress cycles in a bolt, we can also detect more precisely when it will break. So these are examples. We will see, this is only the start. Towards, as we go along, we'll see that everything will have its virtualization, its digital representation, and move us closer to the real cyber-physical world where something that happens to a thing will always mirror in the virtual world. And if you're doing something on the thing, like a control system, like a robot doing an operation, it may first test out that operation in the virtual thing before it exposes the physical thing for it, because if you break the virtual thing, it's okay, because you can repair it, but the physical is a different story.
Excellent, very good, very good. And the use case we saw obviously was wind farms, but obviously it can go far beyond that.
It's anything that moves, It needs to be, well, if it's a physical structure, it can be a robot, it can be a bridge, it can be a wind turbine or a wellhead in the subsea. Everything that is exposed to stresses or to dynamic loads that you will want to find out if it's starting to collapse, starting to degrade, so that you can be preventive about your things instead of reactive.
Superb. Fascinating. I'm looking forward to seeing how it develops.
Well, me too, and this is, as I said, only the start of the development. When we're moving further with this, it will. We don't see the usages any yet.
Arnulf, that's been great. Thanks a million for talking to us today.
Thank you.